Today we're going to look at quadratics that have roots that don't appear on the x-axis. So if you graph these first two functions, the first one is going to look like this. The second one is going to look like this. So what are the roots of each equation? So the first one has roots at x equals plus or minus 1. What about the second one? It has no roots. Well, that's not entirely true. Anytime you have an x squared, you are guaranteed that there are two roots. But sometimes those roots occur in the same place. For instance, if it bounced off the x-axis, so you could have like x equals 3 and x equals 3. Or if it misses the x-axis, we have what are called complex or imaginary roots. So the second one doesn't have any because it misses the x-axis, supposedly. But that's kind of a lie. It's not actually the case. So if we go down, well, do you see any similarities between those two graphs? Right there, if I were to take the one, oh, I didn't move it down enough today. Right there. Well, whatever. So those two graphs are actually the exact same shape. If I were to grab one and move it over, they fit exactly on top of each other. And that's always the case if it's x squared. 2x squared would be thinner, and x squared over 2 would be wider. But as long as the x squared term has a 1 in front of it, the shape of the graph is going to be the same. Now that plus 1 moves the graph up and down, or the minus 1. If there was an x term, like x squared minus 5x, that would kind of shift it left and right. It's more complicated than that, but basically that's what goes on. So if I wanted to find the roots algebraically, x squared minus 1, how would I solve that for x? Add 1 to each side. X squared equals 1. Square root, and we get x equals, what times itself is 1? 1 or negative 1. So it's actually plus or minus 1. And this is a trick that you're going to have to remember forever in mathematics. If you have x squared equals a number, square root is the opposite of square. So this cancels that out. Anytime you do that, you actually create two answers. If x squared equals 1, there are two numbers you can put in for x and still get 1. So anytime you square root an x squared, your answer will be plus or minus. Let's try the same thing on the other side. X squared plus 1, 0. Right? X squared equals negative 1. What two numbers multiply to be? What number turns it stable? Well, 1 and negative 1 are two different numbers. So, alright, it's going to have, that should say what it is the second time. Alright, because that's starting to get. So, if we dispute it, take the square root and say x equals, alright, square root. That's what it is. The square root of negative 1 is. That's going to lead us to defining imaginary numbers. Imaginary numbers come in the form a plus b pi, where a and b are both real numbers. Okay? So every imaginary number, so this is a real number, and this is an imaginary number. And when you put real numbers and imaginary numbers together, we get what's called complex numbers. I already said that
complex and imaginary are basically the same thing, so we're just going to call them the same thing. So an imaginary number could be 5 minus 6i. We consider that one imaginary number. Okay? Um, if you were to graph the real number line, that's the real number line. Okay? Well, you can graph complex numbers if you call this the complex axis. So 5 minus 6i would be right there. Now that's not a normal graph, right? The graph on your calculator has an x-axis that's real numbers and a y-axis that are also real numbers. But that's a complex number plane. And you can see that if all of the real numbers are on this line and all of the complex numbers are here, are there more real numbers or more complex numbers? Complexly, x is a complex number. It would be right here. All real numbers technically are, but there are far more numbers with i's in them than there are with 5 minus 5 minus real number have terribly more 2i. What is that when you do x equals i. So the next one, square root of negative 81. Wait, do I need plus or minus? Did I have x squared equals negative 81? No. How do you write the positive root? I. It's just 9i. So there's a big difference between x squared equals negative 81 and the square root of negative 81. This one, I have two answers. This is just the positive version. Right? It's positive square root of negative 81. So that's, you need to distinguish between those two. If there's an x squared, you will have plus or minus. But this one didn't have an x squared. It just says simplify. And it already told us that it was the positive version. So the next simplify negative root. Do I need an I? Is there a negative inside the square root? Nope. So I don't need an I. So it's just negative 2. So it's asking what is the opposite of the square root of 4? Well, the square root of 4 is 2, and the opposite of 2 would be negative. Okay? Now we're going to add complex numbers. It's really easy. If you have two complex numbers, you just add real portion to real portion and imaginary portion to imaginary portion. It's just combining like terms. So I have 3 minus 4i and 6 plus 8i. What do I get when I combine the real portions? 9. And when I combine the imaginary portions? Plus 4i. Everybody understand that? Right. Just treat the i's like x's for now. But it's going to change here in a second. Okay? That's a fraction problem. So 10 minus 3 is 7. And then I have 8i minus negative 4i, which is plus 12i. So this just says take 8i and then do the opposite of what you refer to it. Well, what's the before we do the multiply one, you need to look at the very strange quality that I have. So you can write this down if you want, or you can just watch. We have defined I as square root of negative
1. I'm going to build a little chart over here that says I equals I. Ooh, that's fancy, right? Well, that happens there. Before I show you that, the square root of what's the equivalent for the square root of 2 point, right? What is the square root of, so there are two ways to the square root of 36, or the other way to write it would be 2.5 self. Well, what is 36? 2.45 times 2.45. 6. So I could say 2.45 squared. Right? So 2.45 squared is going to be 6. How come? What? And 2.45 is actually the square root of 6. Right? So if I took the square root of 6, I could have ignored all of this and squared it and got 6. Why? Right. Squaring and square root is opposite. A minute ago, we looked at x squared root, and the square root was on the inside. And the square root, square root's on the inside, and the square root. So anytime you square a square root, your answer is just whatever's in the middle. So knowing that, what is I squared? Well, it equals the square root of negative 1 squared, which is just negative 1. So I squared equals negative 1, which is something that's never happened before. No. I is the square root of negative 1, and I squared is the number negative 1. So I times I is a real number, which is really crazy, right? Imaginary number times imaginary number equals a real number. Now, any numbers are real. They're not natural or wrong, but they are real numbers. Okay, negative square roots are not real numbers. Okay, well, let's look at I to the third. I'm going to write this out in one line. Root negative 1, root negative 1, root negative 1. What do these equal? Negative 1 times I, right? The third is negative I. I plus an imaginary number, which is So if I add another I to the sixth is negative 1, and if I add a seventh negative 1 times I to the seventh is going to be negative Well, hopefully you see the pattern. I to the eighth is going to be 1. So what we have here is a pattern, and in math we call it mod 4. It had a modulus of 4, which means it repeats every 4 times. Well, there's a very good chance that we'll be write it out, or even count it out. 1, 2, 3, 4, the rest of the time, right? So let's do 87. 21? Oh, okay, 21.75. Okay, what does this 21 tell me? Okay, so if that didn't make sense to you, let me write it a different way. As 87 remainder 3. Very nice. We went in 20.